I'd like to introduce the data rows for the high-pressure range of the saturated steam table. In this range, the enthalpy of liquid starts at 180.07 BTU/lb and continues to increase through 193.5, 216.86, and 234.48 up to 255.09 BTU/lb. The latent heat of evaporation gradually decreases from 970.3 to 920.5 BTU/lb. Continuing the previous trend, the heat required for evaporation is smaller at higher pressures. The total heat rises gradually from 1,150.4 to 1,155.3, 1,163.4, and 1,169.2, reaching nearly its peak at 1,175.6 BTU/lb. The specific volume steadily decreases from 26.80 to 21.08, 16.938, 14.189, 12.226, and finally down to 7.922 cubic feet per pound. Here too, the total heat is verified as the sum of the enthalpy of liquid and the latent heat of evaporation. Adding 970.3 to 180.07 gives approximately 1,150.4. Please also keep in mind that the continued notation at the bottom of the table indicates that the data extends into even higher pressure ranges.
I'd like to introduce the composition of the saturated steam properties table. This table summarizes the physical properties under conditions where steam is in a saturated state, meaning liquid and gas are in equilibrium. The first column of the table is pressure, with units in pounds per square inch. Pressure is listed based on absolute pressure, denoted as P. The temperature column is given in Fahrenheit and represented by the variable T, and the specific volume is in cubic feet per pound, representing the volume occupied by a unit mass of steam. The key point is that under saturated conditions, once the pressure is determined, the corresponding temperature, specific volume, and latent heat are all determined as single values.
This section demonstrates the relationship between gauge pressure and saturation temperature. The left side of the table shows the gauge pressure, and the absolute pressure is the value obtained by adding approximately 14.7 psi to this. For example, at a gauge pressure of 55.0 psi, the saturation temperature is 287.07 degrees Fahrenheit. At 60.0, it is 297.97 degrees Fahrenheit. At 70.0, it is 307.60 degrees Fahrenheit. At 80.0, it is 316.25 degrees Fahrenheit. And at 90.0, it is 324.12 degrees Fahrenheit. In this way, the gauge pressure increases in 1 psi increments up to 99.0 psi, and the saturation temperature rises gradually accordingly. You can see a trend where the saturation temperature increases slowly, by less than 1 degree Fahrenheit, for every 1 psi increase in pressure.
Here, I would like to introduce the latent heat of vaporization. The unit for latent heat is BTU per pound, and it refers to the amount of heat required to completely convert a saturated liquid into a saturated vapor at the same pressure. In other words, it is the hidden heat absorbed during the phase change process, without a change in temperature. Following the latent heat is the heat of the liquid item. Generally, the latent heat of vaporization tends to decrease as pressure increases, which you can verify specifically in the subsequent numerical data.
This part introduces the heat of the liquid. The heat of the liquid is measured in BTU per pound. This value represents the sensible heat, the heat that is explicitly observable, required to heat the liquid from a reference temperature of 32 degrees Fahrenheit up to the corresponding saturation temperature. Adding the latent heat we saw earlier to this heat of the liquid gives the total heat. In the table, the total heat follows the heat of the liquid, followed by the specific volume, so that by looking at a single row, you can understand all the thermal properties at that pressure.
Now I will go through the numerical section where the heat of the liquid, latent heat of vaporization, total heat, and specific volume are listed together. Each row consists of 4 values. For example, the first row shows a heat of the liquid of 256.30 BTU/lb, latent heat of 919.6, total heat of 1175.9, and a specific volume of 7.787 cubic feet. When the heat of the liquid is 270.60, the latent heat is 909.4, total heat is 1180.0, and specific volume is 6.378. Looking at this entire section, as the heat of the liquid increases from approximately 256 to 298, the latent heat of vaporization decreases from about 920 to 889. On the other hand, the total heat increases gradually from 1175.9 to 1187.0. The most prominent change is in the specific volume, which decreases significantly from 7.787 to 4.474 cubic feet. This directly reflects the fact that as pressure increases, the volume occupied by the same mass of vapor becomes smaller.
Finally, this part introduces the area where the header system repeats as the saturated steam table continues into the next pressure range. Since the table is long and spans multiple pages, column headers such as pressure, temperature, and specific volume appear again. The pressure column is in pounds per square inch and is based on absolute pressure, P. Temperature is in Fahrenheit, denoted by the variable T, and specific volume is expressed in cubic feet per pound. In short, you can understand that the saturation property data for higher pressure ranges continues in the same format as what we have examined.
I would like to introduce the section of the saturated steam property table that deals with the correspondence between pressure and temperature. This table organizes the gauge pressure, absolute pressure, and the corresponding saturation temperature side by side. In the gauge pressure range from 100 psi to 104 psi, the absolute pressure corresponds to 85.3 to 89.3 psi, and the saturation temperature rises from 327.81 degrees Fahrenheit to 330.66 degrees Fahrenheit. In the 105 to 109 psi gauge pressure range, the absolute pressure is 90.3 to 94.3 psi, and the temperature is 331.36 degrees Fahrenheit to 334.10 degrees Fahrenheit. This is followed by the 110 to 119 psi range, where absolute pressure is 95.3 to 104.3 psi, and temperature is 334.77 degrees Fahrenheit to 340.62 degrees Fahrenheit. The 120 to 129 psi range has an absolute pressure of 105.3 to 114.3 psi and a temperature of 341.25 degrees Fahrenheit to 346.73 degrees Fahrenheit. And the 130 to 144 psi range reaches an absolute pressure of 115.3 to 129.3 psi and a temperature of 347.32 degrees Fahrenheit to 355.21 degrees Fahrenheit. What is noteworthy here is that the difference between gauge pressure and absolute pressure remains constant at approximately 14.7 psi, which is the atmospheric pressure, and that the saturation temperature increases monotonically as pressure rises.
I will now introduce the column header items used to distinguish the numerical columns in the saturated steam property table. This part corresponds to the table header and defines the latent heat of vaporization item. The unit is expressed in BTU per pound. Latent heat of vaporization refers to the amount of heat absorbed when water undergoes a phase change from liquid to vapor at the same temperature. This is followed by the heat of the liquid item, which also uses the BTU per pound unit. This header row serves to distinguish which property each of the following numerical columns represents.
I would like to introduce another column header in the saturated steam property table. The heat of the liquid. This item, labeled as heat of the liquid, uses the unit of BTU per pound. The heat of the liquid refers to the amount of heat required to heat water in a liquid state from a reference temperature, usually 32 degrees Fahrenheit, to the saturation temperature. This value is added to the latent heat of vaporization we saw earlier to calculate the total enthalpy of the steam. This part also corresponds to an item in the table's header row.
I'd like to introduce the first section of the saturated steam properties table, where the values for sensible heat of liquid, latent heat of evaporation, total heat, and specific volume appear together. Taking one row as an example, when the sensible heat of liquid is 298.40 BTU/lb, the latent heat of evaporation is 888.8. The total heat of steam is 1187.2 BTU/lb, and the specific volume is 4.432 feet superscript 3/pound. Here, the total heat is calculated as the sum of the sensible heat of liquid and the latent heat of evaporation. Adding 298.40 and 888.8 gives approximately 1187.2, which matches perfectly. Following this section, as pressure increases, the sensible heat of liquid increases from 298.40 to 327.13 BTU/pound. Conversely, the latent heat of evaporation gradually decreases from 888.8 to 866.3 BTU/lb, because the heat required for the phase change decreases as pressure and temperature rise. The total heat of steam increases gradually from 1187.2 to 1193.4 BTU/lb, and the specific volume decreases from 4.432 feet superscript 3/lb to 3.134 feet superscript 3/pound. A decrease in specific volume means that the steam becomes denser as the pressure increases.
I'd like to introduce the column header row of the subsequent pages in the saturated steam properties table. This section defines the headers for pressure, specific volume, and temperature. Pressure is denoted in pounds per square inch, or SI, and specific volume uses cubic feet per pound. The temperature item is the T value expressed in degrees Fahrenheit, and absolute pressure is represented by the symbol absolute P. This header row serves to distinguish whether the following numerical columns represent pressure, specific volume, or temperature.
I'd like to introduce the high-pressure section of the saturated steam properties table, from a gauge pressure of 145 psi to 270 psi. First, the range from 145 to 149 psi is listed in 1 psi increments, corresponding to an absolute pressure of 130.3 to 134.3 psi and a saturation temperature of 355.76 to 357.89 degrees Fahrenheit. Then, the range from 150 to 158 psi has a wider interval of 2 psi, with absolute pressures from 145.3 to 153.3 psi and temperatures from 363.53 to 367.45 degrees. The range from 160 to 178 psi continues with absolute pressures from 155.3 to 173.3 psi and temperatures from 368.41 to 376.64 degrees. The range from 180 to 198 psi covers absolute pressures from 175.3 to 205.3 psi and temperatures from 377.51 to 389.86 degrees. Finally, the range from 200 to 245 psi widens again to 5 psi increments, reaching absolute pressures of 210.3 to 255.3 psi and temperatures of 391.79 to 407.78 degrees. As we move toward higher pressures, the table is condensed as the pressure increments widen from 1 psi to 2 psi and then to 5 psi. The difference between gauge pressure and absolute pressure remains constant here at approximately 14.7 psi, which is atmospheric pressure, and the temperature increases monotonically.
I'd like to introduce the column configuration of the saturated steam properties table. This table contains various physical properties of steam in a single row for a given pressure and temperature in a saturated state. The column indicated in this segment is the latent heat of evaporation, which represents the heat required for evaporation, with the unit being BTU/pound. Latent heat of evaporation refers to the amount of heat required to completely convert a liquid into steam of the same temperature at the saturation temperature. The columns of the entire table consist of pressure in psi, temperature in degrees Fahrenheit, and then sensible heat of liquid, latent heat of evaporation, total heat of steam, and specific volume, where the unit for specific volume is Ft superscript 3/pound. This segment itself is a table header that was separated due to a page break, so you should read it in connection with the numerical rows that follow.
This segment points to the sensible heat of liquid column of the saturated steam properties table. Sensible heat of liquid, referred to as heat of liquid, is the amount of heat required to heat water from a reference temperature to the saturation temperature at a given pressure, with the unit being BTU/pound. There is an important relationship here. The total heat of steam is the sum of the sensible heat of liquid and the latent heat of evaporation. For example, if the sensible heat of liquid is 327.7 and the latent heat of evaporation is 865.8, the total heat of steam will be around 1193.5. As pressure and temperature rise, the latent heat of evaporation tends to decrease while the sensible heat of liquid increases. These values are used directly for heat balance calculations of valves and steam systems, calculating condensate amounts and drain design. Since this segment is also a header separated by a page break, please view it together with the numerical rows.
I'd like to introduce the actual numerical rows of the saturated steam properties table. Each row is read from left to right in the order of sensible heat of liquid, latent heat of evaporation, total heat of steam, and specific volume. The units for the first three are BTU/lb, and for specific volume, it is Ft superscript 3/pound. The sensible heat of liquid starts at 327.7 and gradually increases to 383.7. Conversely, the latent heat of evaporation gradually decreases from 865.8 to 818.5. The total heat of steam, which is the sum of the two, rises gradually from 1193.5 to 1201.9. In fact, 327.7 plus 865.8 equals 1193.5, showing that the sum of the sensible heat of liquid and latent heat of evaporation matches the total heat. The specific volume decreases significantly from 3.114 to 1.7107, which means that as pressure increases, the volume occupied by the same mass of steam becomes smaller. These values are used to determine the flow rate and cross-sectional area of steam piping, as well as the heat quantity.
This segment shows the headers for the pressure, specific volume, and temperature columns of the saturated steam properties table. Here, pressure is expressed in pounds per square inch, specific volume in cubic feet per lb, and the temperature variable is lowercase t in degrees Fahrenheit. The key point is that this section is based on absolute pressure, or absolute P. Since absolute pressure is the sum of gauge pressure and atmospheric pressure, which is 14.696 psi, it corresponds to the gauge pressure column within the same table. In a saturated state, once the pressure is determined, the saturation temperature and specific volume are automatically fixed, as pressure and temperature are linked as points on a single curve called the saturation line. Since this segment is a header, you should read it along with the numerical rows before and after it.
This segment contains the numerical rows for the high-pressure range of the saturated steam properties table. Each row consists of gauge pressure, absolute pressure, and saturation temperature, with temperature in degrees Fahrenheit. This covers a relatively high pressure range, from 275.0 to 1200.0 psi gauge. Adding the atmospheric pressure of 14.696 to the gauge pressure gives the absolute pressure. Looking at the saturation temperatures, they rise from 409.43 degrees Fahrenheit at 275.0 psi gauge to 486.21 degrees Fahrenheit at 600.0 psi gauge, 544.61 degrees Fahrenheit at 1000.0 psi gauge, and up to 567.22 degrees Fahrenheit at 1200.0 psi gauge. As pressure increases, the rate of temperature increase gradually slows down because the slope of the saturation curve becomes flatter. This table is a continuation of the saturated steam properties table and connects to the next page column.
Finally, I would like to introduce the header for the latent heat column on the continuation page of the saturated steam properties table. The unit is BTU per lb, and this header corresponds to the high-pressure range data we discussed earlier. As pressure increases, the latent heat of vaporization continues to decrease, converging to zero near the critical point of water, which is approximately 3,260 Celsius and 705 degrees Fahrenheit. At this point, the distinction between liquid and vapor disappears. The relationship where total heat is the sum of liquid heat and latent heat holds true across all pressure ranges. When designing steam heating or determining steam trap capacity, the heat released as steam condenses, the latent heat, is the critical value. Since this segment is a split header, please interpret it together with the adjacent numerical rows.
I will now introduce the continuation part of the saturated steam properties table. This table serves as a reference for boiler and steam piping design. Pressure is given in Celsius and Sig, and temperature in degrees Fahrenheit. Heat of liquid, latent heat of evaporation, total heat of steam, and specific volume are organized together in one row. All units are in BTU per pound and cubic feet per pound. This specific segment is the header for the heat of liquid column, which represents the enthalpy of 1 pound of saturated water based on 32 degrees Fahrenheit. The numerical values in the body of the table will be covered in the following segments.
This segment contains the actual numerical rows of the saturated steam properties table. Each row consists of 4 values: heat of liquid, latent heat, total heat of steam, and specific volume. For example, the first row is 385.21, 816.9, 1,202.1, and 1.6804. The first 3 values are in BTU per pound, and the last is in cubic feet per pound. As pressure rises, the heat of liquid increases from 385.21 to 571.7, while conversely, the latent heat decreases from 816.9 to 611.7. The total heat of steam rises from around 1,202 to 1,204.6 and then drops again, because the decrease in latent heat outweighs the increase in liquid heat. Specific volume decreases significantly from 1.6804 to 0.3619 as pressure increases. You can confirm in every row that the total heat is nearly equal to the sum of the heat of liquid and the latent heat.
This segment corresponds to the header part of the pressure, temperature, and specific volume columns in the saturated steam table. Pressure is expressed in pounds per square inch, and here the absolute per column begins. The temperature variable T is based on degrees Fahrenheit. This table is structured to use pressure and temperature as indices to read the corresponding liquid heat, latent heat, total heat, and specific volume. Absolute pressure and gauge pressure are provided side by side, so that field instrument values and absolute pressure can be used together.
This segment covers the high-pressure region of the saturated steam table, with data from 1,250 Sig to 3,206.2 Sig. Each row lists gauge pressure, absolute pressure, and the corresponding saturation temperature. For example, 1,250 Sig corresponds to an absolute pressure of 1,264.7 and a saturation temperature of 572.5 degrees Fahrenheit. The final row of the table, 3,206.2 Sig, corresponds to an absolute pressure of 3,220.9 and a saturation temperature of 705.40 degrees Fahrenheit, which is near the critical point of water. As pressure increases, the saturation temperature increases steadily from 572.5 degrees Fahrenheit to 705.40 degrees Fahrenheit. This page is a continuation of the saturated steam properties table.
This segment is the header part for the latent heat and total heat columns corresponding to the high-pressure range pressure and temperature rows. The latent heat of evaporation represents the heat required for saturated water to undergo a phase change into saturated steam at the same pressure, expressed in BTU per pound, followed by the total heat of steam column. This segment contains only the headers. Specific numerical values are provided in the next connected segment. Throughout the table, Latent heat decreases as pressure increases because the distinction between liquid and vapor disappears as it approaches the critical point.